All right, let's talk Desmos. So really, let's just jump right into it. I've got just the Desmos graph pulled up, desmos.com/calculator, or just go to desmos.com and hit start graphing, and that'll bring you to this very graph setting. I'm going to slide this out a little bit so we'll read the commands a little better while also zooming in. So hopefully you can read that okay. So the big boy for Desmos is normal dist. We're not very clever with our names. And then we're going to open our parentheses and we're going to type in not four numbers, but just two numbers. And the two numbers that we're going to type in is mean first, comma, standard deviation. So mu, comma, sigma. So if I remember correctly, the mean height was 70 and the standard deviation was 4. Now, as we've played with in the other graphs in previous videos, that's caused the graph to slide way out there, right? On the graph right now, I have 0, 1, 2. I'd have to go all the way out to 70 before I start saying anything. But I don't really want to see the normal curve. I know what a normal curve looks like. Instead, I want to do this for calculations. So I'm going to hit this checkbox, and this is just pure beauty in my opinion. Because what I can do with this is I can say, well, I don't really care about a minimum, but I want to be below 60 inches tall. And wouldn't you know it, there it is. That's what we found in the previous two videos using both the Z-tables and Excel. Now Desmos will do it for you as well with normal dist. Conversely, for the other example, I want to be above 84 inches tall. So now I don't have a maximum, so I'm going to delete that limit and just type in 84 as the minimum. And it will give me the probability of being above 84 inches. Same as before. So far, so good. And actually, what I really like about this one is just by having no limits at all. Of course, I have just one because that's the area of the whole thing. That's the probability of everything. Everyone is somewhere on this graph. But you can also very quickly find just about anything else you want, really, right? If I want to be between 6 foot and 7 foot, all I've got to do is put in the appropriate measurements in inches. And it will immediately calculate that for me. In fact, if you want to be turbo fancy, and who doesn't, you can set these to all be variables that you can just type in various bars here and have it update automatically in the calculation. Of course, that's advanced stuff. We don't really need to worry about that. Now, some of you might be really upset with me saying, well, Mr. Terrell, what about that third part? What about the inverse? Okay, fine. If you want to do the inverse, you'll do normal dist, and then you'll type in dot inverse CDF, and then you'll type in the probability you want. So this is super advanced. I really wouldn't worry about this personally. It's not nearly as gorgeous as the normal dist command. But if you do want to do inverse cumulative probability distributions, you can. There's a command for it. And once again, 71.76 inches. That's what we found in the previous two videos for the 67th percentile. You can find it in Desmos as well. Now, if this is overwhelming you, I do have some good news for you. I have prepared a a, a graph basically that I will share with all of you that has a lot of things that you can play with, right? This was the graph where we can slide everything around. We can change the mean. We can change the standard deviation. Oh, don't make it negative. That doesn't make any sense. Standard deviation is always positive. But you can basically type in whatever mean you want and whatever standard deviation you want. If you want to make it the standardized normal curve, then your mean is 0, your standard deviation is 1. And then you can just play with the normal dist here and have it calculate for you the areas you want. And I've got some other things here that you can play with as well. So hopefully I'm giving you enough technology to help you do your calculations. And have a good one.